Right. I suggest you pause the video so that you can read this question. Right, number 6.1. Work done by the cyclist on the bicycle. Work done by the cyclist is equal to the force applied by the cyclist multiplied by the displacement times cos theta. Now we're going to say the cyclist is applying 20 newtons multiplied by the change, that's the displacement, 32 multiplied by cos the angle between the displacement and the surface. In this case it's going to be 0. So we say 20 times 32, which is 640 joules of energy. That is the work that is being done by the cyclist. Alright, use the work energy theorem and calculate magnitude of velocity of the bicycle at 32 meters. So number 6.2, work energy theorem. Net work done on an object is equals to change in kinetic energy of the object. So the net work done can be calculated by saying net force times change in x cos 0, which is equals to the change in kinetic energy half the mass of the object v final squared minus v initial squared. This could be one way of solving it. So for you to be able to calculate net force, let's draw a free body diagram here, right, and look at the forces that are acting on this object. So if I'm to draw a free body diagram here, I do have the force of gravity acting on it, I have the applied force, and I also have the frictional force. Now to simplify this, I'm just going to draw one here that includes all the other forces. I'm going to split the forces into its components. So in this case we have the applied force here, we're having the frictional force. Don't forget we must have the force that is parallel, the parallel component of gravity. Then we have our normal force, and we will have the perpendicular component of gravity. Now in this case we are more interested in these three forces to get a net force, that is the net force that is moving these objects up here. So to get that net force, I'm going to say the net force F net is equals to the applied force plus the force of friction plus the parallel component to gravity. The applied force is 20 plus a negative 11 plus we need to calculate the parallel component. We do have the angle. The parallel component is going to be 6,1 kilograms. Remember, it's going to have a negative because it's going in the opposite direction. Negative 6,1 times 9,8 times sine 10. Right, when you add all this up, you should be able to get the net force is going to be minus 1,388 newtons. Now we're getting the net force with a negative. That means there's a net force on the down the slope. So you come here and you're saying minus 1,38 times the 32 times cos 0 is going to give you 1 is equals to half the mass. So we're talking of half of 6.1, which is 3,05. So we're having 3,05 multiplied by v final squared minus v initial squared. Right, so you do your mathematics solving it. So we have minus 0,45 from this one and dividing by 3.05 is equals to V final squared minus 5 squared. So the minus 5 squared is going to give us a minus 25. We're going to add that 25 to this side. So plus 25, which is going to give us a 24,54 is equals to V final squared. Then we find, by finding the square root of that one, which is going to be equals to 4,95. So 4,95 is going to be the velocity, meters per second. That is going to be the final velocity of the bicycle. So 6.3, the work done by friction on a system results in a change in total mechanical energy. In other words, frictional force, the work done by frictional force on any system depends on the path that is taken by the object. That is why we call them non-conservative forces. Remember, conservative forces, the work done by that force does not depend on the path. It simply depends on point A and point B, from where it starts to where it ends. So frictional force is one of non-conservative force. In other words, frictional force is going to take some energy from the system. There are other non-conservative forces that actually add energy to the system. So as long as a force changes the total mechanical energy of a system, then it is not conserving the energy of that system, and we regard it as non-conservative force. Okay guys,